Okay, ready? Now we're going to start introducing matrices. Okay, so let's do the definition of a matrix. Okay, so the definition of a matrix, we have an M by N matrix. A matrix is a rectangular array of numbers with M rows and N columns. Each number in the matrix is called an entry. Okay, so here's an example of a matrix. So we use bold capital letters to denote a matrix. Now, we could use parentheses or square brackets to determine, to write a matrix, okay? So in this case, they're using parentheses. Now, each element, for example, this is a 2 by 3 matrix, 2 rows, 3 columns, okay? Now, each entry, like for example, each entry has a corresponding way of describing it. So I wrote in, and the notation might be different depending on the textbook, but this would be entry 1, 1. Sometimes they put a comma, so it would be 1, comma 1. It's always the row first. You always have the row listed first. So this is the entry for row 1, column 1, row 1, column 2, so E1, 2, E1, 3, which is row 1, column 3. And then down here we go to E21, which is column 2, row 2, column 1. And then we have E22 is row 2, column 2. And then E23 is row 2, column 3. Now, notice that E12 is not necessarily the same as E21. Okay? So the order of those subscripts matter. Okay? Here, the element, the value of E11 is 1. 2.2 is E12, right? And so those tell you where the elements are located, or the entries. Okay? That's how we denote the matrix. Okay? So in other words, we would say E1, comma 3, let's say, is equal to 5. E2, comma 2, or E22 is equal to 4. Okay, and so that's the definition of a matrix, and entries. Okay, now when we use matrices, now also keep in mind these columns represent the variables, right? So the numbers here, these are all the coefficients of each linear equation. So this is the coefficient of one linear equation. These are the coefficients of the other linear equation. So this column represents the x's, this column represents the y's, and this column represents the z's. So if I wanted to rewrite this, this would be 1x plus 2.2y plus 5z. Okay? For example, for that linear combination, not linear equation, but for that linear combination and so on. But again, I'm getting a little ahead of myself, but that's kind of where we're going. But before we get to that, just realize a matrix in general is this. Okay? So this represents a matrix along with its entries. Okay, and then what we're going to do is we're going to use all of the pretty much the same elementary row operations on a matrix to get to the same result. Okay?